Right. So just get this last people set it. I didn't expect that many people here, so that's very nice. How many people here have been looking into data lakehouses before? A few, right. It's an introductory session, so some of the things might be familiar to you, but for the rest, at least I hope I can give some information. So welcome to building a data lakehouse in Azure. First of all, as you've seen before, and you will see the next 2 days, a big thanks to the sponsors. Without them, we couldn't be here. I'll first try to set the setting. Why are we talking about lakehouses? What's so different between that and data lakes and data warehouses? And then I'll look closer at what a data lakehouse is, and more importantly, what is a lakehouse file? And then in the end, we'll go through how to build that in Azure and do some demos on how this works. So first of all, enterprise data warehouse. I suspect a lot of people here have been working in data warehouses. It's been around longer than I have worked here, despite my gray hair, or white rather. It evolved over time, and the data warehouse is good because it contains structured data on writes, schema on writes. It is relational, and it stores the historical data that needs to be transformed. And typically you transform that data before you load it, and it is good for business decisions. How are we doing today? How have we done this last week compared to a year ago? And it is good because it is doing cross-system querying. You can query across your ERP system, your sales system, your point of sales, blah, blah, blah. And this is something that is important in a warehousing environment. However, that also means that you need to be really careful loading that data in. It's being used for business decisions. It has high data quality focus. You need to have exact numbers, which means that you get long development life cycles. So the business gets what they ordered after they've forgotten what they ordered. Which also means, of course, that we have a bad repetition in data warehouses, that they are huge projects running for a long time and really, really expensive. Which is, of course, no longer true, but it still sticks with us. Then we have the data lake, and data lakes gained foothold around 2011, and it tries to answer the pains that relational database systems faced when we got the big data part in. And big data, normally you talk about the V's, and depending on which marketing department you're talking to, there might be 4 or 5 or 6 or 10. But volume, variety, and velocity of the data. So the amount of data that is going into a relational database, the velocity of that data as it streams in, puts a strain on those systems. You could, of course, throw more CPU and more RAM on it, but still the nature of the relational system, the ACID support, so making sure that the data was being consistently displayed, means that relational databases struggled. So the data lake was the answer that was suggested, and the typical varieties of data lakes are raw, so you just dump everything in there, and then you can let the business users sift through that themselves. And then you have a business data lake, or a layered data lake. And the layered data lake, you land all the information as is, then you encourage line of business to create point solutions, so you let the business users go in and transform the data themselves. You let them decide on the cost performance of their problem, which lets IT just focus on making things running. And the corporate view, i.e. the data warehouse, is just another line of business problem, so it's somebody else's challenge to maintain and develop. And of course, unstructured information, videos, pictures, and so on are also information, which is not typical in a relational database. But of course, you can never assume that the data lake contains everything. You need to go out and hunt for more if that is the case. Data lakes are scalable, so they can scale up and down by demand because it's basically just disk space. The problem, of course, is that the classical Hadoop on-premise data lakes were a pain to administer because adding more storage nodes was quite a hassle. So the benefit of this is that you can have various use cases and various users getting access to the various layers of that data lake. You have data engineers and data scientists typically want to go to the raw data as close to the source as possible, whereas business analysts might want to have data that is being curated to a certain amount so that all timestamps are in CET, all numbers are 2 digits and so forth. But because the data lake is not curated and not transformed consistently by a single team, you can't be sure of the data quality, which means that as its nature, it is very good for trends and ad hoc analysis, but it doesn't really give you that enterprise view, unless you start developing it and then you're going back to a data warehousing in all but shape. But this also means that a data lake has a very short time to market life cycle, which is really popular among business users waiting for their problems to be solved. Problem, of course, with the data lake is the more you pour in, if you don't put governance on it, you'll have a problem with the data swamp. There is so much data lying around there that nobody understands how to use or where it even is. So you're just paying for a lot of storage, which is, even though it's cheap with disk, it still amounts up. And data lakes lack that ACID support, so atomic, consistent, isolated, and durable, which is typical for a relational database, which means that everything is just files. You cannot delete, you cannot update or insert, as you can do in a traditional database. And because it's files, you will need to combine all those files and serve the result closer to the user. So depending on the compute nodes that the users have access to, it can be quite slow, whereas a database is tuned for specific versions or types of queries. And the amount of businesses that had the data warehouse installed, I think Gartner in 2014 claimed that the data warehouse was dead. Is it? No. Because everybody has put a lot of money in it. Why should we throw it away? It works. So, and data lakes cannot fill the shoes of the data warehouse unless they take on the form and shape of one, and then also those slow development life cycles. And that is why Databricks had the data lakehouse installed. Okay, Databricks came into this as a containerized Spark engine. It's popular for big data querying, processing, and that was just about it. And then Databricks itself has evolved over time. I'll talk more about what they have done. But as part of that, they coined the lakehouse in 2019. And it's, of course, a very clever way of combining data warehouse and lake together. I'm not very fond of it, but it sticks. So it delivers both the data warehousing part of your reporting, as well as big data analytics over a data lake, which means that it can empower self-service BI, as well as analytics and data science. But you'll still need to have a proper compute in place to serve that data on large data sets. And of course, unless you have proper governance on it, the amount of data growing, you can still run into a data swamp. And of course, that is also part of it, is knowing what data is high quality and curated and what data is not as high quality or haven't been defined yet. So you have to be wary of what you can trust or not. Data lakehouses should have, according to this blog post that Databricks launched, it has to have transaction support. It has to have schema enforcement and governance. So schema on write instead of schema on read, which is typical for a traditional data lake. It has to have support for BI tools. It has storage decoupled from compute, and this is important because a traditional database, even though if you pay for it on-prem, it's free. Whereas if you put in more disks in a relational database system on-prem, you don't really think about it. It's sunk money. In the cloud, where you do pay as you go, the larger the database, the more you pay. And a database is always on. So you pay for a combination of compute, memory, and storage. If you just take that storage and you pay for what you use in the storage, and then only pay when you calculate the storage afterwards, it is a lot cheaper. Maybe something like 1/5 of the price. So a table in a data lakehouse can be 1/5 of the price of a SQL database table. So it makes sense that you want to have that separated. It needs to be open. So open source. It's your data, it's your format. You can take it with you. You can develop that format as you want. And it has to have support for various data types, geography data, pictures, blobs, whatever. And diverse workloads. So streaming, batch, and so on. And it has to be end-to-end streaming. So you can stream data through the lakehouse without having to wait for all the transactions to hit in as you do in the relational database. And the core of the lakehouse, according to Databricks, is Delta Lake. However, there are several different lakehouse files. And I guess some people here have heard about Delta Lake, yeah? Okay, not that many. But the files are the heart of the lakehouse, and they are open source. They bring ACID principles to the files. So they are lakehouse files is a bit wrong, actually. It's more a wrapper program around compressed binary format. So typically it's Parquet, but one of them also supports Avro and Orc. And they can be stored wherever, so S3, ADLS, on-prem HDFS, if you want. Of course, there are S3 on-prem versions, alternatives available. For instance, MinIO is an S3 compatible storage, object storage on-prem. They are unified batch and streaming source and sink, so you can load data into and out of it during batch, or you can stream data through. They bring schema enforcement and schema evolution. So schema evolution is if you insert a new column to a table. The existing data in that column or that table will of course have a column with null values, but every new row that comes in with that column in will get values in. And Delta Lake or Lakehouse files bring that to the table. And then you have transaction logs, which means that you can do time travel. You can look backwards and see, okay, how was my row last week? Who has done anything with this table since last week, last month? It depends on the size of your transaction log. And it supports merges, updates, deletes, and audit history. Delta Lake has files underneath in Parquet. As I mentioned, Iceberg supports also 2 other formats. Out of those 3, you have Apache Iceberg. That's made by Netflix. It is, for those of you who have been working with Snowflake before, you might not be surprised that Snowflake has picked Iceberg as, I mean, everything Snowflake does is something snow or ice. But it is not Snowflake that made Iceberg, but because it is not, Delta Lake is from Databricks. So of course, Snowflake and Databricks being the huge catfight at the moment, Snowflake cannot or will not only support their competitors' format, even though that's now also open source. Then you have Apache Hoodie, which is from Uber, and Delta Lake, which is a part of that was open sourced by Databricks to the Linux Foundation. They open sourced that in 2 rounds, so it was only last year that they were fully open source. And all 3 can run on Spark. A variety of different computes sources such as Flink, Trino supports most of them. But natively in Azure, Delta Lake is the one that is supported. I had this fantastic idea that I would show you Hoodie here today because I read the blog that they had made Hoodie work in Synapse. But of course, the demo gods hit me hard and it didn't work. So it's probably because there's an upgrade, just launched a new version of Hoodie, and that the new changes to that library didn't support the commands that were published. So we'll demo Delta Lake later on. So because there are so many different versions, which should you look into? Okay, there are companies that have based their entire existence around Iceberg. For instance, Dremio, which is an open lakehouse competitor. But I thought this benchmark that was run in January was quite interesting. This shows a TPC DS benchmark, even though benchmarks themselves typically are only used for sales purposes. This was done by an independent Databricks consultancy, and then added upon by a Hoodie consultancy afterwards, who did the same benchmark. And Delta and Hoodie overall outperforms Iceberg, as you can see, by a lot, both in reads and writes and in total. Feature-wise, if you compare them, Hoodie seems to be the best match because it has the most support. It supports primary keys, it supports 3 different indexes, whereas Iceberg and Delta only have support for 1. But, and of course, yeah, I've been working a lot with open source people, and one of their benchmarks for being a quality open source is the variety of committers to the repos. And Delta Lake has the fewest different people committing, but that is because those committers are coming from Microsoft and Databricks, but mostly. Whereas Hoodie and Iceberg have a variety of different versions. Again, look where the money is. Databricks and Microsoft have go all in on Delta Lake. Of course, they will be the ones that are committing to it. But for this session now, since I couldn't show you the Hoodie part, Delta Lake is at the heart of the Azure Lakehouse. And a typical architecture will look something like this. Databricks coined the medallion structure. And the medallion structure is, for those who have been working with data warehouses, you have this ODS or a stage, then you have your EDW, and then you have your data marts, typically. And this is what you find here in the medallion structure: bronze, silver, gold. Bronze is your raw layer, so as close to the source as possible, stored in Delta Lake tables. Then you have silver, where you have curated your EDW, and then gold, your data marts. But it's very popular to talk about medallion structure now, and I've seen a lot of business users seem to find that easier to understand than ODS, EDW, and data marts. So I've started using it a lot myself. But that's the storage layer. You store that wherever you want, and because it's open source, it's supported by open source query engines. It's supported by BigQuery in Google, as it's in preview right now. Snowflake also recently announced a preview of support for Delta Lake. And of course, out of the box in Synapse and out of the box in Databricks, Delta Lake format is there for you. So you can take those files and those folders and move them with you if you get annoyed by Microsoft, or you find that AWS gives you a better price. You move everything without having to start transferring or changing everything from Oracle to SQL or Snowflake to Redshift or whatever. You can just take the files with you. And then you build you choose your query engines of choice, and then connect Power BI or Databricks or Tableau or something else on top. So again, from a typical, very basic architecture overview, This will be your data warehouse solution in the cloud. You have your sources on the left, so MySQL or SQL or Oracle or Salesforce or whatever. You have some sensor data that's streaming in. Then you have an ETL job that takes that data, transforms it, sends the live data into a message queue, sends everything else to a Parquet file. Then the message queue has an ETL job on the other side that pulls that data onwards and streams that into the streaming analytics. Whereas the ETL job takes the Parquet files, transforms that to new Parquet files, which are then being loaded into a data warehouse, or 2 or 3 or 4, and then being used by BI users, or you have the data scientist connecting to one of the Parquet files underneath, which is all fine and dandy. Parquet are quite effective in compressing. It's like if you're using Power BI, you have the Vertpack engine underneath. You have your columnar data sets that are very effectively compressed. And Parquet does the same. It's columnar binary row sets that are being compressed. And each Parquet file is roughly the same size as the data or row set in Vertpack or in column store indexes. Slightly different algorithms, but it's mostly the same effect. Anyways, then you have your Delta Lake coming in. You have an ETL job that takes that data, streams it into the Delta Lake, or batches it in, depending on the source. Then the second job, instead of having to listen to a message queue, it can listen to that Delta Lake table and stream that onwards for analytics. Or you can have your ETL job connect and transform the data coming into the Delta tables into separate new Delta tables. And then you connect whatever compute power you have or you want on top, and people can query that directly. Even Power BI, you can connect to a Delta Lake table directly and query it if you want. So yeah, as I mentioned, it's compressed files in a data lake, so it's cheap storage versus a database. It's compute needed only on read. You don't have to pay for it unless you use it. And you just select which endpoints you want to use. So that is serverless SQL, it's an external table in Synapse serverless pools, or staging tables in Snowflake. Doesn't matter. I'll just look a bit into how the Delta Lake tables look like. Let's see if we can. Oh, come on. And of course, this took time now. Oh, come on. Yeah, there's demo goals hitting me bad. Oh, look, there we go. So from a browser perspective, if you go into your object store, ADLS in this case, you will find the Delta table being one folder, and underneath you have your log file, and then you have your partitions or your row sets as Parquet files. So each of these are Parquet files containing roughly 1 million rows. Then you have your log, which is JSON in Delta Lake, in the Delta Lake. Hoodie and Iceberg have slightly different approaches to this, but from this side of view, it's a JSON file, and then you can open this if you want. There's a bit slow connection down here, it seems. Oh, well, it doesn't really matter. So yeah, you can look at the JSON objects. You can edit them if you want to ruin things. But typically, this is all you get. Everything else is that wrapper, that Delta Lake program that resides in your Spark nodes. Takes care of everything else for you. But it means that you have highly compressed. You have to, of course, to be a bit careful when you partition it. You can define your partitions yourself if you bulk load a lot of data in, or you can just let Spark do the job for you. So Databricks, as the inventor of Delta Lake, they moved from being, as I mentioned earlier, a pure Spark container engine to something much more. They have announced a lot of features the last years. You have Photon, which is a analytical query engine. So as in SQL Server, for instance, when you're doing column star indexes querying, it doesn't really perform very well until you start doing group bys or sums or advanced analytical queries. And that is where Photon also comes in. It is a C++ engine on top of native Spark, which is written in Java. So Databricks found out that certain kind of queries did not perform well in Java, so they created Photon to lie on top. And Photon is not enabled by default when you create a Databricks cluster. It's something that you enable afterwards, or when you're creating it, you can check off that it is a Photon enabled, and that comes with a premium price. So do that only if there are clusters where you know you will be using these analytical query engines, because otherwise Spark or Databricks will only look at the query plan and it will say, okay, but none of these really need Photons, so I'll just use Spark natively. And then you're paying still double instead. Serverless SQL, which means that you no longer have to commission your Spark clusters and have them running for users to be able to query the data in the Delta Lake. Those serverless SQLs are hosted by Databricks and they're not part of your tenants, but they connect to your workspace, and you can then, I'll see if I can, for some reason I've gone out of my cluster permissions. I'm not allowed to do anything, but as you can see here, I have my tables and I can start querying. So for anybody who have analysts that want to run queries over your Delta Lake or your Lakehouse, they can go into Databricks or they can go into Synapse and query directly there without having to think about, is the cluster up and running yet. Then you have Delta Live Tables, and Delta Live Tables are ETL, is an ETL tool within Databricks, which is quite handy. It's like DBT, you can use it to create script libraries. It has native support for slowly changing dimensions, so you can insert or merge into table X using SCD2, and it will handle all the logic behind your slowly changing dimension 2 as part of that without you having to explicitly type it out, which is quite nice. And Unity Data Catalog, which is their data governance tool. For some reason, right now, it's not possible to use Unity Catalog on Delta Live Tables. So if you're using Delta Live Tables, sorry, you have to wait until Unity Catalog works with Delta Live. But it's something that they're working on, hopefully soon. They also launched or announced that they have acquired another data governance company last week. So they're also betting a lot on expanding their data governance tools within Databricks. And all these are components that are essential in the data lakehouse architecture. Yeah, you need somewhere to store it, you need some serving options, and then, of course, you need to let your users find that data and then know what that data can be used for. And yeah, you need, okay, without the lakehouse, at least when I'm out hiking, I need to serve some coffee and waffles. You need to serve your data somehow. So using Databricks, you will then have the Photon engine I mentioned, the Delta Live Tables, Serverless SQL. And one thing I've forgotten, there's something called SQL Pro, which is also launched this year in preview, which is serverless SQL, but hosted by you. I haven't looked into that yet, so I can't talk a lot about it, but it's another feature that is coming in. And then, of course, Unity catalog on top to make sure that users can find out where the waffles they want are. Synapse is, Synapse is one of several options in the Lakehouse. But of course, Synapse is more than just the name. It's several different services. You have your Azure Data Factory, which is ETL. And you have SQL Serverless. You have your SQL Data Warehouse, which is horribly named Dedicated SQL Pools. Then you have Azure Spark, which is Azure Spark Pools. Synapse Studio, which is the workspace that we're working in. And Azure Data Explorer or Data Explorer Pools. And for those of you who don't know what Data Explorer is, it is a really powerful time series analytical database. And I've been using it in some projects recently, and I've been really, really fond of it. But in this setting, it allows you to do data lakehouse, enterprise data warehouse, time series analysis in one single workspace, in one single notebook if you want, which is quite nice. And then, of course, you have stream analytics, so live analytics over data streams. And right now, you cannot really do Azure machine learning as part of it. You can, of course, develop your machine learning using Python in notebooks on Spark. But you can also use Azure machine learning as a separate tool with a lot more powerful machine learning setting. And then export your machine learning models using Onyx, which is an open source format, and import that into your dedicated SQL pools. And then you can run machine learning on your data warehouse data inside SQL. So Synapse Analytics, as I mentioned, it was the second data lakehouse compatible system defined by Databricks. There are a lot more now. As I mentioned, Dremio is a pure lakehouse company. You have AWS coming in saying that Redshift is now a lakehouse system. Yeah, maybe. And then, of course, Snowflake also. It's again, with every other buzzword, lakehouse, data mesh, everybody screams, oh, this is also data mesh. So this is the same here. But in Synapse, you have native support in Azure Spark for Delta Lake. You can also do the pipeline, so the Data Factory part has support for Delta Lakes as source and sink. And serverless SQL pools reads but cannot write, but that's the limitation in serverless SQL anyways. So it's, and of course, Power BI, as mentioned, also supports it. Which means that you have on top Microsoft Purview catalog to lead your users through there, and then they have Synapse workspace where they can start browsing, and then they can hit everything else, or we can build everything else of the data lakehouse using Synapse. As for how that will look, so let's first see how this will look in, I think this was the one I had last time. Oh, come on. I just switched views. So how this will look when you're working in Python, which is the easiest. You can also use a combination of Python and SQL. You can load the data into a data frame. In this case, the yellow cab, New York yellow taxi files are very easy to work with because they're freely available and they're quite big data sets. So I've dumped that into my storage. I load that into a data frame. Then I create a view on top of that. Then in SQL, I will create a table. It will always take the schema default unless you start writing or creating new schemas. Default is the one that is, in SQL is DBO, in Databricks is default. You define your columns, and then the important part here is that you use delta. You define delta as the source, as the target, and then you point it to the folder where that data is residing, or should reside. And when that is done, it is also then created in the Hive metastore. So if I now try to create it again, I will get an error saying it's already existing in Hive. And then I can run that first so you can see, because I've changed from the first one. I added another file. Oh, it's stopped. Okay, never mind. I forgot to start them. I'll see if I can do that here as well. It's a problem when you run demos, because you are, of course, always pressed on the amount of money, so you need to shut down your clusters. But if you forget to start them before your session starts, it will take some time to get them warmed up again. So while that's starting up, you can then insert data into the table that you've created using traditional, this is Spark SQL, not T-SQL. So you insert it into the table by selecting from the view that you already created. That will load in the number of rows, in this case, 7,800,000 rows. And then you can start selecting from that as with any other table. You do order bys, you do anything you want. Again, it's Spark SQL, so it's a bit limited, but it's easier to understand from as long as you're familiar with T-SQL. And it will return you a table with the data inside. Then you can do updates, and right now I can't do that because it's still starting. See if the other one is done the same. It's still starting as well. You do updates, you do deletes, you do merges. And the merge logic is, of course, it's an upsearch. So you check if it's existing, then you update, or otherwise you insert. And then afterwards, you can go in and look at the history of what's been done to that table. And if you see some problems, you regret, or you notice that one of your colleagues have done something dumb, or they've done a mistake, you can roll back to a different version. So in this case, using Python, you can look at the versions that you have residing in the log, and you can then roll back to a previous version of the table, and everything has been changed. Okay, demo gods. When you do the same thing in Synapse, it's almost the same syntax as in Databricks. Slightly different because Databricks is entirely native to Data Lake, but here you need to define a bit more. But the challenge or the benefit is that, at least in my experience, when I'm working with Spark SQL, in Synapse I can actually define, if we see in Databricks table, everything is string. Because it started kicking off when I started inserting data, it started kicking, say, well, you defined vendor ID as an integer, but it is a string. That doesn't happen in Synapse. It's the same file, but Spark SQL or Synapse Spark handles the implicit conversion from CSV string to an integer internally. And it's running, so let's see. I've done something wrong with this with the Databricks cluster. It's placed in Norway East, and for now the quotas on the Spark Spark clusters is bad, so I wasn't allowed to start anything. But now I'm loading data into the table. See if that's done. Yeah. Then I need to import some Spark commands. It will check if the table exists, and then it will just ignore it afterwards. I insert data into the table. Again, it's the same Spark SQL command as in Databricks. So you can still do an update afterwards. It normally doesn't take this long, but I guess that's demos. So, as we go along here, since things are taking so long, one of the things, of course, when you're designing your data lakehouse using Delta Lake tables, you need also to be, I mentioned you need to think about partitioning, but you also need to think about how large your transaction log should be. How long should you keep data there for the rollback? Yes. So it started working again, good. This means that you can, right now in Delta Lake, there is a command called vacuum, which means that you can, vacuum as it says, it cleans out your transaction log. That is a manual job right now. So you have to actually go in and define either a data factory or a Delta Lake table or something else, or a job that runs that vacuum command every month or every week or what's every size you want, because of course you can have a transaction log for a year if you want, but if there are lots of changes so that transaction log grows too much, it will slow down the performance of your Delta Lake tables. So it's important to have that vacuum job running. Hopefully they will come up with a more automatic way of doing it, but right now you have to define a notebook saying vacuum and the tables and the amount of time it should stay or store, and then have that running for you. Otherwise, it will just keep on growing. Right, so I did some changes earlier. I just started that running. I updated the table and changed the vendor ID where the pickup location and drop-off time was something. And then when I go into the transaction log using describe history, I will get a return telling me what has changed. It will also tell me, right now it's just me here, so it doesn't store it, but it will also say which user has done that update or that change in the table. And then, of course, you can roll back the versions here as well. I didn't work. Okay. Which versions do we have? It's probably the version here. No. Okay. But as you see, it's basically using Python SQL. The wrapper, the internal wrapper of Delta Lake program handles everything for you, partitions according to the instructions, and then saves it. And it does update, support, and everything for you. So it's really as easy as using a SQL database. And I'm done on time. Thank you very much. My name is Johan Ludvig. Hope it was entertaining, and if there are any questions, please feel free to ask. Otherwise, it's lunch, so yay!